Artificial intelligence and data science are transforming our world at an incredible pace, and many people are eager to be part of this revolution. However, there is a common misconception that building AI is simply about writing clever code. The reality is much richer and much more interconnected. True mastery in AI and data science does not come from a single skill, but from the powerful synthesis of three core pillars: mathematics, computer science, domain-specific knowledge. Think of it not as a single subject, but as a meeting point where different fields converge to create something truly remarkable. This intersection is what makes the field so powerful, but it also presents a significant challenge for learners and educators alike. Many aspiring AI practitioners start by jumping directly into programming libraries, TensorFlow, PyTorch. While this hands-on approach is exciting, it can often lead to a superficial understanding. Without a firm grasp of the underlying principles, a student might be able to run a model, but will struggle to debug it when it fails, improve its performance, or adapt it to a new, unseen problem. It is like being able to drive a car without knowing anything about the engine. You can get from one place to another on a clear day, but when something goes wrong, you are left stranded. To truly innovate, we must look under the hood. This integrated nature is the core challenge we face in AI education today. Traditional university programs often teach these subjects in isolated silos. Linear algebra course in the math department, data structures course and computer science marketing course in the business school. This separation forces the student to build the bridges on their own, leaving many feeling lost or discouraged. The path forward requires us to intentionally and explicitly weave these threads together, creating a cohesive learning experience. Our goal must be to design a new educational framework. We need to move beyond teaching individual components and focus on teaching the connections between them. When we show a student a mathematical formula, we must immediately follow it with the line of code that implements it and the real-world problem that it helps solve. This holistic approach demystifies AI, transforming it from a black box into a transparent and understandable tool. It empowers learners not just to use AI, but to think critically, creatively, and effectively about how to build and apply it for the good of all, At the very heart of every sophisticated AI model lies the elegant and powerful language of mathematics. It is the bedrock upon which everything else is built. Without a solid mathematical foundation, the complex algorithms that power modern AI would remain incomprehensible mysteries. Key disciplines like linear algebra calculus are the essential tools that allow us to describe and manipulate data in meaningful ways. Linear algebra provides the framework for representing data as vectors matrices. This is fundamental to how neural networks process information. Images text financial time series. It is the grammar of data representation. Calculus is the engine of learning in AI. It is all about understanding change optimization. The core learning process, known as gradient descent, is a direct application of differential calculus. It lets a model incrementally adjust internal parameters to minimize error and improve predictions. When a student lacks conceptual understanding of derivatives gradients, they may still call a function like model.fit, but won't truly understand training dynamics. That gap prevents diagnosing training problems. If mathematics provides the language of AI, then statistics provides the compass for navigating the vast and often choppy sea of data. Data is the fuel for machine learning, but raw data is rarely clean, perfect, or straightforward. It is filled with noise biases and random variations. Statistics is the discipline that gives us the principles and techniques to handle this uncertainty, to distinguish meaningful patterns from random chance, and to make valid inferences from limited information. Without a strong statistical mindset, a data scientist risks building models that are not only inaccurate, but also dangerously misleading, leading to flawed business decisions or reinforcing societal biases. Section 4. The Computer Science Engine. Turning ideas into action. Computer science is the powerful engine that takes abstract math and statistics into tangible, working AI systems. It is the bridge between theory and reality, An elegant mathematical idea is only useful if it can be implemented efficiently in code. To process real-world data at scale, this requires a strong foundation in computer science principles, including programming, data structures, algorithms, systems design. A person who understands the math but cannot translate it into a functional program will be stuck on the sidelines. This is why coding is such a fundamental skill for anyone in the AI field. Proficiency in programming, particularly in languages like Python, is the most immediate and visible skill. However, effective AI development goes far beyond simply knowing the syntax of a language.